This is kind of more of a presentation on advancing of projects that we do in the transportation and the architecture and engineering. Just to introduce TranSystems, we're an architect and engineering firm, and we do all kinds of different types of projects, but primarily focused in the transportation industry. And that could be with railroads, airports, seaports, roadways, transit, supply chain, industrial facilities, automation that goes on inside there, and even some of the quick service type operations that you have in restaurants and hospital facilities. We have a full-time practice area dedicated to operations modeling and analysis, and it's exciting because we get to get involved with a lot of different types of projects. But some of the more interesting things we've been doing to augment and support our simulation efforts is to use GPS data. We've had a number of projects that we've done for port and even for waste collection routes to help cities plan how they should better organize these types of operations. We've even done some work with GIS to kind of supplement some of our modeling to provide the different metrics and things that we need to integrate into the data sets. And then we've also got involved with some server deployment applications where they can have like global access to the AnyLogic models, and those are particularly interesting to get involved with. We are a transportation and architecture and engineering firm, and there's a variety of tools that our company has to help out our projects. We have railroad-specific tools. We have, traffic modeling that gets into very detailed intersection-type modeling. We have even things like quantitative risk management-type modeling, and just all these travel demand modeling. But what we focus on in our practice is to maybe use those tools when they make sense, and a lot of times they do. But then there's a lot of projects that really don't fit the bandwidth of some of these other tools, especially when you get into multimodal operations or transportation systems that have to integrate, processes and things like that. So we use AnyLogic for a lot of those types of problems, and we'll talk about a few of them we've done in the airport over the years. Worked with a lot of different industries, ports, railroads, industries. These are just a small fraction of them. Just talking about large transportation facilities like airports or ports or facilities like railroad corridors. They really do require a lot of planning. There's multiple phases that you go along in some of these large projects. From very early on, you do some very preliminary feasibility analyses. Then when you move on, you get into more detailed comparisons. And the one thing that's a challenge with a lot of these projects is that there's a lot of stakeholders. You've got multiple operators that are even competitors of each other. So there's a natural kind of concerns on these stakeholders to make sure that this thing's facility is going to operate properly. You even have to work with an airport authority that has a budget and things like that have to be managed. You have a multimodal system where you have different types of things. You have to integrate trains, vehicles, buses, people, all kinds of things. So that becomes a challenge. And when you have these large projects that go on for could be years to get them going, it's important to get support and cooperation along the way. One thing you find that I found from working with architects is that they constantly have an issue that has to be presented and agreed upon. And a lot of times the modeling that we get involved with, an issue may come up in a moment's notice that we weren't even planning on, and then they say, hey, is there any way you can model this? And it has everything to do with like how they should arrange something because of a fire issue or what have you. And that's where the modeling using AnyLogic has become really useful, because you can really create a model that's pretty useful to communicate and understand in a relatively short period of time. And dynamic modeling really provides that way to do it that is kind of difficult to do other methods. And you don't have to have a complicated model to do some of this stuff. Some of these models I'm showing here that were done very rapidly just to address a very important concern to keep the project on schedule. One thing we've learned from working as a inside of an architecture and engineering firm, the engineers are very good at coming up with designs. They're very eager to look at the lay of the land and the footprint of a site and come up with a design that meets the general objectives of a particular project. But there's a lot of things that those kind of designs don't necessarily incorporate. Some key questions, whether can the volume or service targets of a facility be met? It's very hard to measure that in just a drawing. Is the design cost effective? Does it really produce what we need in the most cost-effective way? Sometimes that's not necessarily the case. You can test multiple alternatives and find that maybe another solution or a trade-off of infrastructure and policy or rules can possibly give you that. And that's the kind of the theme that we have, is that we use the modeling analysis as part of the engineering process so that we can kind of iterate and kind of come with that productive and useful solution. And it's kind of a very interesting process to go through with, especially with like the airports that I'm going to show. And we've been finding in the transportation industry, we can use modeling for pretty much everything across the timeline of a project, all the way from just very initial visualization and feasibility, where you can really do a model with very, very rapidly and say, hey, does it even come close to meeting our objectives? And sometimes you can find out that you have to redesign it right there. But then most commonly we get involved with proof of concept or proof of engineering modeling, where there has been some work already done, and now we need to confirm and compare different alternatives, or possibly do what is in the architecture field called is value engineering, where you may have an initial design, but we find that putting it all together with the costs, it needs to get reduced, and they try to figure out, is there a way we can do more with less? So those are the kind of the common themes that we get involved with, but we've worked throughout the space here. First, I'm going to talk a little bit about consolidated rental car facilities. They're called CONRACs in the industry, and I'm sure many of you who have rented cars have been in one of these facilities. They're becoming more and more popular at large airports, and we've worked with O'Hare, LAX, San Antonio, Phoenix. So these are just some of the big airports we've done this. And basically what they are, is, especially like at LAX, which is the one going on right now, is they take all these rental car operations that are all scattered around the airport and bring them into a single like giant structure that uses a common bus systems and all that kind of thing, so that it really makes the valuable real estate that's around an airport more usable, so they justify themselves quite nicely in that regard. But they're more than just a parking structure, which you may kind of think that they're giant parking structures. They're really kind of almost like little factories where you have multiple agencies that are in these facilities. You have brands that each have their own peak demands. For example, some brands are more focused on leisure travelers and some are more focused on the business traveler. So they all have their peaks, and the industry's evolved so that some of the bigger brands have actually leisure and business brands, and they kind of use the cars between their own little brands to kind of keep their fleet fluid and get the maximum benefit of all the cars that they own. They also have integrated fueling facilities, washing and repair. They even repair windshields, change tires, and some of the more basic repairs they do right in these facilities. So what we've learned from working with the rental car industry, that each airport has its own unique demands. Like LAX, for example, Monday mornings, like Monday at around 11 o'clock is a real busy time, because that's when all the transcontinental flights come in and the business traveler has arrived into LAX. They also have a unique demand that they have a lot of international stuff that happens across the evening. So all of these things come into play when the rental cars have to plan for how much space they need and how many cars they need to have in these facilities. Then we learned all kinds of interesting things from talking to the rental car companies, in that some of the biggest disruptive events can be like college football games, where they have to get a massive amount of cars into a particular market so that they can support all the demands in a very short period of time. not to say that we necessarily design for all these really big events, but we do have to design to the normal case. Like some markets are have a lot of summer activities, so we want to make sure that we can meet those, reasonably peak demands without too much excess. And then you have to have customer access. You got buses or people movers that have to access the facility, and then there's vertical access between the levels, and all of those need to be addressed to make sure that the airports maintain their standards on how much time it takes for the customer to get their car, especially a time-sensitive customer, as well as the vertical access capacity, because a lot of these facilities, like in LAX, are 4 stories high. So anyway, then the rental car agencies are very concerned that they also don't have to spend a lot of labor to be able to operate these facilities. They don't want to have their drivers or their labor unnecessarily driving too many miles or spending too much time, and that's a concern so they can maintain a productive operation. So here I'm going to show the first example for a CONRAC is what we call sizing the deck. That's the big thing that the rental car companies want to have a good mix of cars that they have so the customer can see all the different cars they have, but they also want to be able to have enough space to deal with the surges of returns that go on. So we looking at how well does the deck support the peak demands, because also the rental car agencies do have off-site lots, and they really don't want to be going off. They want to operate pretty much in the confines of this particular facility. So the basic question the different stakeholders, which are the rental car agencies, are interested in, is there enough space for me to operate within the footprint of this building? Am I going to have to be running around all over town getting cars to go back and forth? So they're really concerned about that. So what we do is we proved this with some modeling in AnyLogic, and some of the inputs that we have are the arrival patterns that the customers have, and there's a lot of studies being done in terms of when these customers come before their flights and so forth. And we have that daily peaks, hourly peaks. We have the processing times that they have to do the different things that they have to do to get a car ready and turned around from return back to rental. We have staffing and equipment and some of the normal things that you have in a model. But we provide time-based outputs so that we can get the utilization of staff at every step, how well the facilities are used, and certain metrics so that the different stakeholders can see that this is going to be a feasible operation for them to operate and agree on the project so that it can be moved forward. There, it's pretty hard to see that, but that's an example of some data that we get from the industry experts that collect this data in terms of when the returns and when the rentals occur, and this is one of the primary input tables that we use for the modeling. And here's an example of a layout that one of the architects came up for. This was for O'Hare. So you can kind of see the parking and the lanes for returns, some of the things that you're probably familiar with if you rent cars in these kind of facilities. And that's usually what we use as a basis. We get the measurements and all the different things that go on in these designs into the model. And here's an input screen that we have so that we can test how much space that we're going to allocate for each rental car agency in terms of how much space they're going to have for returns, for on-site storage, and so that we can kind of see if that particular deck design is going to be able to, properly operate from a space standpoint as well as queuing standpoint for some of the other areas. And this is one of the examples of a visualization that the rental cars the companies like to see, is that this is what they're starting of a peak day. This is actually an animation, but I think it kind of shows better in big time slices. It shows that their parking decks are, like one of the rental car agencies, their parking deck is pretty full, the other ones are not. And that's how they would start this peak day, by planning their cars in this way. And that in midday, you can kind of see the green agency that a lot of their cars have been rented because that's a peak rental day for them. And then the other ones, actually the blue is a leisure, looks like it's a leisure brand that had some of the returns happening. So we can kind of help them visualize, okay, this is what your facility is going to look like middle of the day. And then at night, you can see that after their peak is over, the green is pretty much empty of cars, and then the other facility is starting to build up. But this visualization helps them understand what is their typical day going to be like, and help them to agree and to understand how much work are they going to have to do to maintain their operations on these decks. And here's an example of the outputs from that, so you can kind of see how the different agencies have inventory of cars and how they bleed down, and how that green one, you know, if they had to go much longer, they would probably have to start getting off-site cars. So it's kind of helps them to understand if they're going to have enough space. And then we kind of get into some of the quick turnaround facilities that are in there in terms of fueling, and we can kind of show how many fueling nozzles that they're going to need to maintain the turnaround of the cars, because that's really important to them as well. And then they also have the washing. So all these things will help to size how much capacity you need to be able to support these operations. So LAX is another CONRAC that we got into, and this project is on the order of $1 billion, which sounds like a really big investment, and it is, and it's justified because LAX has all their rental car companies spread all across that area, and they can justify it by the amount of space that they're going to be able to save in having it in a single facility. And we got involved with LAX in a number of ways that I'm not going to show any examples of, but we got through in terms of understanding it should be more vertical or horizontally arranged, or more vertical, to help with the fire issues. So we kind of helped understand how the differences between those kind of arrangements, you know, extend the number of hours that it takes to operate and so forth. So we got involved in all kinds of iterations. But one thing that did come up is that ultimately this new rental car facility is going to have a people mover that intersects with one of the upper decks. But unfortunately, with project timing, the rental car facility is going to be done before that people mover is finished. So they have to have an operation that has buses that come and deliver the people to the facility, and vertical access to take them from a ground bus floor level all the way up to the upper decks where the rental car companies are. So there was quite a bit of concern that we'd have enough space for all these buses in terms of the peaks with the morning and international and domestic arrivals. And so we looked at scenarios to kind of understand how the operation changes, or how the facility can look at those particular scenarios. So we used the Pedestrian library to, oops, I'm not sure how this goes back. There's an animation in there, but anyway, there's an animation that actually, there they go, that shows the buses coming in, and we were looking at making sure there was enough bus slot capacity. And then we also wanted to test to see if an elevator concept would be sufficient to get the vertical access. There was a first interest in doing escalators, which we modeled before that, and that worked great, but they saw the cost of it and the fire implications of that, so they really said, we really want to try to do elevators. So we then tested elevators to make sure it maintained the fluid operation, and we have statistics that show how busy they are and showing how much accumulation occurs between the elevators. So that was kind of some of the concerns that we were able to show, and we did this model in about a week. So that's a nice turnaround to help move this idea of an elevator forward. Then here, a final example for an airport. This is not a consolidated rental car facility. This is LaGuardia Airport, which has a Southwest terminal there that's all Southwest, relatively new. And they wanted to add a new Air Canada plane into that facility at a certain time. So to start things off, I mean, an example that it's really not, you don't necessarily have to have a model to figure out that adding a new plane into your area is going to be a problem. And here's a static analysis that we did right before we started doing the modeling to kind of see what the magnitude of the problem. So you can see that the solid line is the number of seats that you have in this particular waiting area. And based on the data that we got from some of our airport experts that studied how much time do people come before the flights arrive? There's a lot of history in terms of how much far in advance do people come to wait for their flights. So we use that actual data. And you can see the Air Canada wants to come in the afternoon about 4 o'clock, or was it 5 o'clock? And you can see that the blue there is the additional people that you're piling on in a time where you already have peaks that are well above the seating that you have. So you can already see from the static analysis there's a pretty significant problem. But the airport really wanted to kind of understand really what does it do to our facility footprint to do this. So we got into the pedestrian modeling to look at the use of the seats, the aisleways, and even the food and beverage area. So people were using that to sit. So we used the pedestrian library, and that was a really good application for this tool in terms of seeing how the effects of all these waiting areas impact the terminal. We started out with a baseline with no Air Canada flight to see how the system operates, and then we kind of looked at different assumptions. That's what's also nice about modeling, is that there's all kinds of assumptions you can test, and when you have a model built, you can really try those and see how sensitive the particular design is to that. And here is the LaGuardia gate area. We modeled all the areas in that particular terminal. And there is a goal generally to have the people that are waiting at their gate or for a particular gate to be in the area that they normally sit. And that was part of the thing that we wanted to test, is to see how far people would have to wait for their plane. So we kind of put that in there. Actually, did that go back again? I didn't wait long enough. That animates. Okay, I guess there's an animation. Well, I think it's actually the animation's at the end, I'm sorry. Okay, here's the different table inputs we put in here. We looked at just the preference for the different gates to use their waiting areas, so we can see how far people would have to wait far away from their gates. And then we had overflow at the food and beverage area if nobody was able to find a spot. This is one of the animation screens, and it just shows how we have the planes coming in, and you have passengers that come off the planes, and we have passengers that are waiting. And so here, with the baseline, there's the old static model we had, and you can see the results, what happened when you have the model results. And it doesn't show anything that's totally terribly different, but it does smooth out some of the peaks a little bit, and it kind of shows you where the people are actually waiting. And this is the scenario without the Air Canada flight. So then we found at 8:22, that there's no overflow used. It's a pretty stable situation. But at 3 in the afternoon, you can start to see that you're getting a lot more heavily utilized, and you see a lot of mixing of passengers at the different areas for the different gates. And then when you add the Air Canada flight at this peak time, which is already a problem, this kind of shows what happens. And this is the animation of that with the outputs from the pedestrian library, and you can see how busy some of these areas get and how much overflow is needed. And this became particularly useful to really show the operators of this particular terminal what adding this flight is really going to do to the passengers in this area, and how they're going to have to really move pretty far into the terminal, into the areas to wait for their flights. That pretty much concludes some of our applications for airports. We've done quite a few things for airports, but this kind of, I thought, gave you a little variety of some of the things that we get into.
Yeah, I just had a question about how you go about validating or just getting buy-in for the facilities that don't exist yet, like the car rental in LAX.
Yeah, that's a good question. Well, we go through all of our assumptions that we put in there. So we put together presentations of our assumptions and our data. and we kind of get agreement with the stakeholders that these are good numbers, and we kind of maybe show them some metrics to kind of to show typical labor usage and things like that to make sure they're in line what they would expect from their experience. So it's kind of a little bit of assumptions and just kind of, does this make sense from your knowledge of the operation? That's usually what we wind up having to do.
Thanks.
Sure.